It is my great pleasure that I announce Alborz Chimie Company, a pioneer in the realm of chemical admixture for concrete and one of the largest superplasticizer producers in the Middle East. With a steadfast commitment to innovation and also quality, Alborz Chimie has continuously set new benchmarks in industry standards and led the way in advancements in concrete technology. Their contribution have not only revolutionized construction practices, but have also laid the foundation for sustainable and durable infrastructure worldwide. Today, we have the honor of hearing from Dr. Janamian, the regional manager of Alborz Chimie Company, who brings with him a wealth of expertise and experience in this dynamic field. Please join me in extending a warm welcome to Dr. Janamian as we eagerly anticipate his insights and contributions to our conference. Dr. Janamian.
Hello, everybody. This is Kambiz Janamian from Alborz Chimie Asia Company, a leading producer of PC superplasticizers in the Middle East. Thank you very much for listening to my presentation, which is about the advantages of using a slump controller and a slump retainer polycarboxylate polymers compared with water reducer ones, which is the most common polymers right now in the world. Let's look at the contents of this presentation. First, we would like to talk about the differences between the slump controller, slump retainer, and water reducer polymers. We will call these two polymers as SR polymers from now. After that, we started with the advantages. First of all, advantage number one, increase the slump retention of concrete. Advantage number two is improvement of rheology behavior in concrete. Advantage number three is about the simplicity of using PC-based admixtures, especially with hard aggregates. Advantage number four is about the production of high-quality SCC concrete. And finally, we will talk about the deficiencies of SC and SR polymers and what can we do for these deficiencies. Before start the subject, I would like to introduce our company, Alborz Chimie Asia. So I would like to ask you to watch this video clip. Okay, thanks. Now, we would like to talk about the differences between a slump controller, slump retainer, and water reducer polymers. First, the difference about the dosage and performance of each polymer in concrete. You see from this figure, water reducer polymer is a polymer with the minimum dosage or highest slump, but drastically losing of slump during time. A slump controller polymer is a polymer with mean value slump, or a little lower dosage than water reducer one. First of all, you will see an increasing of a slump, and after that, losing of a slump. So finally, you will see a polymer that its performance about the slump retention is much better than water reducer polymers. And finally, slump retainer polymers, the maximum dosage or minimum slump, but the best performance about the slump chipping of concrete. Secondly, we would like to talk about the shape of the polymers. We can give different properties according to the shape of the PC polymer. PC polymer consists of a main chain and side chains. For example, here you can see different side chain lengths. This polymer, which has a longest side chain, you can give the best slump chipping by using of this type of polymer. Different main chain length. If you use a polymer with the shortest main chain length, you will give the most water reduction rate at the start of concrete production. And here, the same shape, but different charge density. The polymer with highest charge density will give you the best water reduction at the start of concrete production. And different side chain density. Here, the polymer with highest side chain density will give you the best slump chipping. So, we can design a PC polymer to give special properties according to the shape of the polymers. And by this usage, we can produce slump retention and slump controller polymers. Okay, universal price and availability. About the price, you can see there's no much difference between the price of SR and WR polymers. But about the mean value production amount, you will see 70% water reducer and 30% slump retention in the world. In the market, you can find WR polymers as mother liquid for PC or PC base. So the most production in the world is water reducer one with 70%. But here, by using of the advantages of SR polymers, we would like to encourage you to use more slump retention types. Advantage number one, increase slump retention of concrete. First, by using of retarders, we can improve the slump retention of concrete. Now, what retarders do? First, they optimize the dosage of PC admixture. If you use retarders beside the PC admixture in the formulated of a superplasticizer, you will see the optimization of dosage of superplasticizer. In fact, I can say that you can use a little less PC, pure PC, which could be economical. And also, they retard the setting time, initial and final setting time. It depends on the type of retarder of concrete. So they can help to improve the slump keeping, especially at hot climate conditions. So I can say that for hot climate conditions, it is necessary to use retarders in the formulation of PC superplasticizers because we should retard the setting time of concrete to give the best slump retention. But it's not enough. Now let's see what happens when you use retarders in formulation of admixtures. Here you can see in this figure, we would like to control initial setting time of cement on 90 minutes. If the concrete temperature will be 20 degrees, there is no need to use retarders for giving the initial setting time of 90 minutes. If the concrete temperature rises to 25 degrees, we need 100 grams of pure retarder, not a solution of retarder, pure retarder in the admixture to give the initial setting time of 90 minutes. When the concrete temperature increases to 28 degrees, you will need 250 grams of pure retarder, more than 2 times. And finally, If the concrete temperature will be 35 degrees, you will need 600 grams of retarders. Now let's what happen. Here, if you formulate a PC admixture with 6% of retarder, which is most common in the market, you can find the superplasazes, PC superplasazes in the market with 4 to 6% retarders, and here we use 6% retarders. Okay, so if you need 100 grams, you should use 1.7 kilogram of superplasizers in 1 cubic meter of concrete. And finally here, if you would like to use 600 grams of retarder, you should use 10 kilogram of PCE superplasticizer in 1 cubic meter of concrete. So what happened here? If you would like to produce a concrete with amount of binder 450 kilograms per cubic meter and the target slump of 200 millimeters, here is what's happening here. If you would like to give this target slump with only 1.7 kilogram of admixture, you should use an admixture with total solid content of 50% and 44 solid content of pure PCE. And at the end here, if you would like to use 10 kilogram of admixture and giving the slump of 200 millimeters, you should use an admixture with total solid content of 20% and 14% pure PCE. Okay, so when you use this type of admixture in concrete, you will put too much retardant in concrete. So this type of admixture should be good for hot climate conditions, like the countries in the Sea of Persian Gulf, near the Persian Gulf, for example, with hot climate, hot and humid climate conditions. And here, if you use this type of admixture, you will put a little amount of retardant in concrete. And this type of admixture should be good for cold climate conditions. And for countries like Iran, with hot summer and cold winter, maybe it is better to use these types of admixtures. So the formulation of admixture and using of retarders depends to the project conditions and too much to climate conditions. And now we would like to improve the slump retention by using of these polymers. Here we don't use any retarder. If you substitute, if you would like to formulate a PC admixture and substitute about 50% of water reducer polymer by SC and SR polymers, you can see here the sample admixture. If you use only water reducer, after 45 minutes, you will give the slump about 80 millimeters. You cannot use this kind of concrete. But if you use this formulation, after 45 minutes, the slump will be about 150. The concrete is usable. And if you substitute more, about 70% of the formulation with SC and SR polymers, here it is much better. After 45 minutes, you will give the slump of 170 without using any retarder. So using of SC and SR polymers will improve the slump retentions much better than using retarders. And the best is use a special mixture of water reducer, slump controller, and slump retainer polymer by using of the appropriate amount of retarder. You should use retarders in the formulation of your admixture, even at cold climate conditions. It depends to the project and climate conditions. Now, here you can see a video clip that we compare two types of admixture produced by Alborz Chimie company. First, SRJ contains SR polymers, and the second, HF. It contains water reducer plus retarder, and you can see the performance of these two admixtures in concrete. Okay, now advantage number 2. Improve the moving ability of concrete that you saw in the clip. The best moving ability was for SRJ, which contains SR polymer. Here you can see static and dynamic yield stress of SCC concrete. Here is a concrete made with water reducer PCE, and this one concrete made with SR PCE. You can see here the much higher static and dynamic yield stress of SCC concrete made with water reducer polymer. So the moving ability of concrete made with SR is much better. Besides that, you can see here, decreasing the probability of segregation bleeding by using of SR polymers. Because the viscosity of concrete produced with SR polymer is 18 compared to 13 for the concrete made with water reducer. So higher viscosity will cause decreasing the probability of segregation and bleeding. So finally, we can say the improvement of rheology behavior in concrete by using of SR polymers. Advantage number 3, simplicity of using PC-based admixture, especially with hard aggregate. What does it mean by hard aggregates? Hard aggregates is aggregates with low filler contents or poor sieve analysis tests. Sometimes we should use these kinds of aggregates, especially sands, in the concrete because we don't reach to the good quality aggregates in the area. So at that time, you saw that by using of normal PCEs, we have the problem of segregation and bleeding very much. And here, this is a concrete produced with water reducer polymer only, and here concrete produced with a slump retention polymer. The minimum dosage for giving a slump of 210 millimeters, 0.71 for this and 0.78 for this, a little higher dosage, okay, it's acceptable. But here you can see maximum dosage, higher a slump, but without any segregation and bleeding. For this type is 0.79, but here is 0.95. It means that if you use about 0.2% more admixture in your concrete, you will not see any segregation bleeding by using of SR polymers. So you can use this type of polymer better than water reducer ones.
2 minutes left. You have 2 minutes left.
Okay.
Thank you.
Okay. And finally, advantage number 4, production of high quality SCC concrete. First, best quality of SCC according to the rheological behavior that you saw before slides. Second, no need to redose in the projects according to the best slump retention of admixtures produced by SR polymer. And finally, decreased working time for concrete pouring according to better rheology. You can see this one in this video clip. Okay, it will finish within 1 minute only. Okay, about the deficiencies of SC and SR polymers. First, a little higher dosage. What can we do? Improving the quality of SC and SR polymers. It is the work of R&D of producers of PC in the world, and the universities also. They are trying to improve the dosage of SC and SR polymers, and also using special mixes of polymers. We are not asking you to use only SR polymers. We are asking to use SR polymers beside WR and other types, and also using retarders for optimizing the dosage as mentioned before. And second, different technology for production need higher accuracy and more quality control. What can we do? Buy from a trustable company. Thank you very much for listening. If you have any question, you can reach me. Because of the time management, you can reach me at the stand of Alborz Chimie in the exhibition. Thank you very much.
Okay, we have time only for one question. If there is any question from the floor, could you give the microphone to him?
سلام عرض میکنم وقتتون بخیر. آقای دکتر من انگلیسی سوالم رو بپرسم مشکلی نیست. My dear friend, thank you very much for your appropriate presentation over here. I had a question actually. You have mentioned many different types of variables right here, for instance, about the climate, about the project condition, but something here was, I don't know, forgotten or ignored. Actually, I think the most important variable over here is the mixed design method statement. You didn't even mention how you just designed your mixed design, or I don't know how to say it. For instance, when you are talking about the rheology of the concrete, when we are talking about self-compacting concrete rheology, there are many different variables over here, which for instance, cement, supplementary cementitious materials, the aggregates and other stuff are really important. But if you would kindly please just give us a brief explanation about the mixed design method which you have used for designing this kind of concrete, and which and their impact on the dosage of your admixtures. Thank you very much.
Okay, about the mixed design, there's no difference to use which method. For example, we can use the national method for mixed design of concrete. There's no difference. But of course, the mixed design has much effect on the dosage of superplasticities and also on the slump retention. But the problem that we was talking about is about the using of PCE polymer, special PCE type polymer. When you use slump retention polymers, you can use different types of mixed design procedures for your concrete. I can only say this, but the answer to your question is many time consuming. Thank you very much.
Excuse me, thank you for your presentation. If you start with the same initial slump, because in your example, the initial slump for 3 products were different. But if you start with the same, what would be the results, please?
The results is much better, but you should use a little higher dosage. A little higher dosage. Thank you very much.